Okay, how do we find the vertex of this? Now that's in factored form. And so we can actually see the roots. So what I'm looking at is the fact that either x plus 1 equals 0 or x minus 5 equals 0. So I can see from this that negative 1 and 5 will be where it cuts the x-axis. Okay, so if we want to articulate this a bit more carefully, we'd say to find roots, 0 equals x minus 5, x plus 1, so either x minus 5 equals 0 or x plus 1 equals 0, so x equals 5 or x equals negative 1. How did I do that? The plus 1 on that side, took 1 off both sides, so the minus 1 there, that disappeared, and minus 1 there turned up here. And for this one, the minus 5, so we added 5 to both sides, so the 5 turned up on the other side, and minus 5 plus 5 disappeared. Okay, so we've got these two roots. Now the vertex will be in the middle, right? Because we know that a parabola has a line of symmetry with the vertex in the middle, so wherever these two are, we need to find the midpoint. So to find the midpoint, we'll go minus 1 plus 5 divided by 2, so that's going to be 2. So we know our x equals 2. How do we find the y? We go back to this equation. So y equals 2 minus 5 times 2 plus 1, which equals negative 3 times 3, which equals negative 9. So let's just have a look at what that means. That means the x coordinate is 2, the y coordinate is negative 9. So that there will be positive 2 and 9. All right, let's just quickly go to here and, well, not there, that's it here. You can see there, here is the vertex, here's the equation, and so that's all proof of it being correct. All right, that's not what this video is about, 3 minutes into it. What I want to show you is how to put this into the vertex form. So I'm going to do this an entirely different way. So let's just select that, Control C, we'll select all, we'll delete it and Control V. Okay, so I'm going to do this in a different way. So this time we are going to put it into vertex form. So vertex form is y equals a x minus b squared plus c, where a is the shape and b comma c is the vertex. So how do we do this? First thing we're going to do is expand. Y equals, we're using FOIL, x squared plus x minus 5x minus 5. Then we're going to collect like terms. So the only two that were like terms were those two. Then here I'm going to complete the square. So complete the square. Y equals x squared minus 4x. To complete the square, I actually take the minus 4x, halve it to get minus 2x, and then square it to get 4. But I can't randomly add 4 without randomly taking 4 off. And then we've still got the minus 5. Okay, so now I can look at this. And I completed the square so that I could write x minus 2 squared. I can factorise that. And then here, these two are minus 9. So if I compare it, my minus b to the minus 2, I can see b equals 2. And if I compare plus c with minus 9, I can see c equals negative 9. So I can see that my vertex is 2, negative 9. All right. So this completing the square thing, it's a happy thing to do, I feel. Maybe you want a bit more explanation. You can stop watching now, or you can listen a little bit more. And so, yeah, if I had, for example, x plus a squared, that's x plus a times x plus a, which equals x squared plus ax plus ax plus a squared, which is x squared plus 2ax plus a squared. That's why I can half it and square it. An example, x plus 1 squared equals x squared plus 2x plus 1. See daisies, x plus 3 squared. We can do it the long way, x plus 3, x plus 3. So it's x squared plus 3x plus 3x, so that's plus 6x, and then plus 9. So you can see here that if I halve that, I get 3, and 3 3s are 9. If I halve that, I get 1, and 1 times 1 is 1. Okay, so whenever you've got this here, to find this term, all we have to do is half that number and square it. That might be enough, but let me try to show you some examples. So if I had x squared minus 10x, or x squared plus 8x, or x squared minus 12x, to complete the square, I would halve this and square it, so it'd be plus 25. But I can't just randomly do that, so quite often I'd have to minus 25 as well, depending on the context, right? But at the moment, because we're just completing the square, we know that we've got to add 25. Here, half of 8 is 4, 4 fours is 16, half of negative 12 is negative 6, negative 6 times negative 6 is 36. And so these you would understand factorises to x minus 5 squared, that factorises to x plus 4 squared, and that factorises to x minus 6 squared. So what is the purpose of being able to do this? Because here we've got 2 x's, and this expression we've only got 1. So completing the square is actually how the quadratic formula came about. But it's also quite good in parabolas because we have our y equals ax plus b, cx plus d. That's our factored form. We have y equals x minus a squared plus b with a shape, or we could do that x minus b squared plus c. That's our vertex form. And we can call this the roots or the factors because this is where these are important, whereas this is when that's important. And the other one is standard ax squared plus bx plus c. Now, the c in here and here and here is not the same c, right? They're just variables of whatever, showing the constants. So we can move, if we went back to that other one, we actually had it started in that form, we expanded it to get it into that form, and we completed the square to get it into this form. This form, we can see the vertex very easily. This form, not so easy to see, but we can see the y-intercept very easy and the shape. And then this form here, we can see either x equals negative b upon a or x equals negative d upon c. That those are the roots. Okay, so have a play. Good luck.